All right, so we are doing a couple of example problems for Chapter 17. It says, it is generally believed that nearsightedness affects about 12% of children. The school district gives vision tests to 133 incoming kindergarten children. What's the probability that in this group over 15% of the children will be nearsighted? Make sure to identify the sampling distribution you use and check all necessary conditions. All right, so the type of sampling distribution we are having, this one's going to be a proportion. The reason is they didn't give us a standard deviation, so we're going to have to calculate it. And that's pretty much, that right there tells you. So I know that P is equal to 0.12 because they gave us that. N is equal to 133, and the proportion that we want is equal to 0.15. All right. So now to check our conditions. First thing we want to check is independence. And they don't tell us that they gave us a random sample, so we're going to assume it's a random sample. All right. Also, 133 children will be less than 10% of all kindergartners. And then the next for the normality, we have our large counts. Do we have a large enough sample? And the way we're going to do this is we're going to take the number. So remember, with our large counts, it's going to be n times p. Has to be greater than or equal to 10. So that would be 133 times rp, which is 0.12. It needs to be greater or equal to 10. Use your calculator. And 133 times 0.12 gives me 15.96. And that is greater or equal to 10. So it meets that one. Now we also have to check our failures. So n times 1 minus p is also going to be greater or equal to 10. So that's 133 times 0.88. Okay. All right, so now do the same thing, 133 times 0.88, and that's 117.04. It's going to equal to 10. So we meet the large counts, and so we can apply a normal model. So conditions met. All right, so now, if we look at, we're looking for P, the probability that P hat is greater than 15%, 0.15. So if I were to sketch this, here's my 0.12, 0.15 is right here, and I am looking for this. I'm looking for the right tail. All right, so then I know that my lower bound, I'm going to use normal CDF. My lower is 0.15. My upper is 999. My mean is going to be P, which is 0.12. And I need to find the standard deviation. I haven't done that yet. So to find the standard deviation of P hat, that's going to equal the square root of P times 1 minus P divided by N. and that is the square root of 0.88 times 0.12 divided by 133. All right, and so second square root, 0.88 times 0.1233, and that gives me 0.028. Okay, so this is at 0.028. Using my normal CDF, my lower bound's 0.15, upper bound is 999. 0.12 and 0.028 gives me a probability that over 15% of the children, it's going to be 0.142. So there is a 14.2% chance that of this group, in this group, over 15% of the children will be nearsighted. And to write your context, guys, just restate the question. All right? All right, let's move on to the next one. Wildlife scientists studying a certain species of frogs know that past records indicate the adults should weigh an average of 118 grams with a standard deviation of 14. The researchers collect a random sample of 50 adult frogs and weigh them. In their sample, the mean weight was only 110 grams. One of the scientists is alarmed, fearing that environmental changes may be adversely affecting the frogs. Do you think this sample result is unusually low? Explain and use statistics to support your answer. Okay, so let's talk about our information we have here. We know that the average weight is 118. So that is our mu is 118. And the standard deviation is 14. And we have a random sample of 50 adult frogs. So n is equal to 50. Of that sample they took, the mean weight of that sample was only 110. So the mean weight, so that's of a sample, so that's x bar is equal to 110. Did that adversely affect? Is the environment adversely affecting the frogs? So let's do this. So we need to check our conditions. So the first condition is random. Well, it told us, or excuse me, the first condition is independence. And it told us it was a random sample of 50 frogs. Also, 50 is less than 10% of all frogs. Okay, so far we've met that part. Now we need to do our large counts, or also, do we have a large enough sample, I should say. And that's based on the central limit theorem that says we need to have 30 or higher things in our sample. Well, our sample is 50, and 50 is greater than or equal to 30, so that checks. So we have a large enough sample, and we have shown independence, so we can say conditions are met. for a normal model. All right. So we want to see if this result is unusually low. So that means we want the probability that X bar is less than the 110. All right. So if I go back to my normal model, here's 118. 110 is going to be way over here because, all right. Actually, hold on here. Let me go back a little bit. Let's calculate our standard deviation. So let's calculate the standard deviation of X bar. And that is going to be the standard deviation of the population divided by the square root of n. So that's 14 divided by the square root of 50. And that gives me a standard deviation of 1.979. So if I'm thinking about this standard deviations, 118 is here, 110 is 8 away from it on the left. That's more than 4 standard deviations, so it's going to be kind of a small value. So 110 is going to be somewhere around here. But now let's use our normal CDF. It's just something to think about, is look at your standard deviations, look where your value is, so you kind of have an idea going in what your percent should be. So this tells me it's going to be a really, really small percentage. My lower bound will be like negative 999. My upper bound is going to be the 110. Remember, the mu of X bar is the same as mu, which is 118. And the standard deviation of X bar is we're going to use as 1.979. We're going to put that in our calculator. And I get a p-value of 0.0000, a probability to 6. So that this is unusually low. That's a very, very small probability for our sample. So therefore, maybe it is happening. We might need some more information. So they might want to be a little bit alarmed because it's a very low, unusual result. Okay. All right, so I've gone through, so hopefully this has helped you with a little bit. If you have any questions, let me know.